Okay. Yesterday, we were introduced to our two basic trig graphs, sine and cosine. We also got introduced to three of the types of transformations with a vertical shift, an amplitude, and an ROX. This one has two of those things in it. So just reminding you of where we start all of this, we always mark our x-axis with those 4 tick marks, labeling the fourth one as the period, which until today has been 2 pi. That we kept in mind our vertical shift and our amplitude as we labeled our y-axis. In this one, we need to go all the way up to 2. Then we drew our midline based on our vertical shift. Our midline should be moved up 1, just like the rest of this graph is all moved up 1. That sine starts at our y-axis on the midline. No matter where we move sine, it will always start on the midline. Okay, so our first dot for our sine curve would have been here. The ROX does not impact us until we draw the second dot on sine. Because of the ROX, instead of going over 1 up our amplitude, we would go over 1 down our amplitude being 1, and now we have our pattern set. So then I just follow my pattern. So next tick mark, I return to my midline, next tick mark above, next tick mark, return to my midline, fill into the left. So I was below, we have to alternate. So I was below, midline, above, midline, below, midline. Nice smooth curve to connect my dots. Today, we're gonna get the last of our transformations. So things that we have not looked at is a horizontal shrink or stretch, and then also a horizontal shift, right or left. So we're gonna add that in today. Jumping into that, a horizontal shift, right or left. Last semester, we would have called that the ill part of ill route. Okay, inside it moves us right and left. But in trig graphs, that has a specific name called a phase shift. So when you have a plus or minus a number inside your function, meaning inside the parentheses, the function is actually listed as minus c, c being your phase shift, opposite of the direction we think it should go. Positive actually moves us to the left, negative moves us to the right. Luckily, we are used to that because that is the same we've always seen with our transformations. So what does that do? It moves where we start the first dot. Other than that, once we again figure out the pattern fills in like normal. It's just kind of where we kick off starting the pattern. Okay. So just to give us something to work with, here's an example. This has one transformation, and that is a plus pi over 2 on the inside. That's the only transformation going on here. What we need to understand again, inside is always opposite, so that's actually going to move us left pi over 2. Now, sometimes you will be asked to identify these letters A, B, C, and D. You can't use words left and right when you do that. So to indicate left, we would actually say negative. Your C or your phase shift is actually negative pi over 2 because in the function there's already a negative. So the negative is why it is a plus when we see it. Okay. So moving that then to our picture, first of all, I would have my midline not moved because we don't have a vertical shift on this one. Normally, sine would have started then at my y-axis on my midline. But because of our left pi over 2, instead of starting at my y-axis, I would put that dot on my midline to the left pi over 2. Here's negative pi, here's pi over 2. That would be my starting dot instead of at the origin. Once I figure that out, there is no ROX and there's no amplitude change. There's nothing else. Now my pattern goes like normal. So from there, I would go to my next tick mark up 1. Next tick mark, I would return to my midline. Next tick mark down 1. Midline, up 1. Fill into the backside here 2. Down 1. Midline, up 1. Now, I do want to share with you that these start all looking alike because now doesn't that kind of just look like a cosine curve? Yeah, and that's okay. You do not ever have to mark your starting dot like I did. And what you'll notice on my answer key today is that my starting dot is always a different color. You don't need to do that. I understand how you did this. Yeah, you could make a mistake and end up at that same picture. It's possible, okay? Doesn't happen often, but you kind of luck out if you do. But this is not a requirement. You don't have to tell me where you started by any way, shape, or form. I just want you to be able to see it on the answer key to help you with how I got the picture I got, okay? Any questions on your phase shift? New vocabulary for us. Let's try one more with a phase shift. Okay, so this one we're going to try y equals cosine of x minus pi. You're going to want to do some of this today. So again, we have to think opposite. Minus actually tells us which direction. Right. And again, to be clear, that means my phase shift or my C value is a positive pi. So my midline didn't move. My period length didn't change. My amplitude is still 1. The only change we have is where we're going to put that first dot. Don't draw this. My first dot normally for a cosine curve would be at the y-axis, but 1 above my midline. This is where I would have normally put my first dot. But because of the transformation in this one, I'm supposed to move it right pi. So that dot actually will end up being right 2 tick marks, right pi. And then we fill in from there. So right now I'm above my midline. I would go to my midline, 1 below. Same thing back this way, midline, 1 below. Midline above, midline below. Questions? Now, stepping back and ignoring the blue dot, doesn't that kind of look like a different way of writing a cosine curve? It would have been a cosine curve with a what? Yeah, an ROX, yeah? Well, that becomes our entire conversation Thursday, but if you can kind of start seeing those things, it makes Thursday really easy, because what happens is I can write actually an infinite number of different equations to describe this same picture, because I could write it like as a sine curve starting here. We just have to mess with like the phase shift and the ROXs and things like that, and which function we're describing it as, because they're all the same. Questions? Okay. Our last transformation then would be a horizontal shrink or stretch. Now, your horizontal shrink or stretch impacts what is called the period, the amount of time on the x-axis that it takes us to complete one curve. Very, very important is that you understand that this is related to, but not the same as the number b, the multiplication number you see in your equation. So these two equations that I'm going to put off to the side here, highlight and make them super important in your notes, is that the period of the graph is always going to be 2 pi divided by that b number we see in our equation, and vice versa. B is always going to be 2 pi divided by the period. And usually whichever one we need, they give us the other one. So we'll always have to do 2 pi divided by to get what we want. When we draw this, there are kind of 2 techniques to approach it. One of those is very challenging. That's not the technique we use. Okay, the other one actually makes graphing these very easy. We will continue to mark our x-axis with those 4 tick marks in each direction the same way we always did. And what that does is it gives us a spot to put all of the dots appropriately for each of our curves. What we're going to do is change the labeling. We will always label our 4th tick mark as the period, and we'll label the 2nd tick mark as half of whatever that number is. Okay. Now there's a couple comments I want to make before we move on from that, just so you know. So not doing this example yet, but if, like, for example, I find out that the period is 10 pi, I would also label this as half of that number, 5 pi. Don't let the pi distract you, right? Now that's not usually what people have trouble with. It's more when we start getting into fractions. What if I told you that the period was 2 pi over 3? This one always trips people up. 2 pi over 3. And I'm supposed to label The second tick mark is half of that number. Well, what's half of 2 pi over 3? It's kind of intimidating at the first, but it's like 2/3. What's half of 2/3? 1/3, right? Yeah, think about it in those terms. This is 2/3, and half of 2/3 would be 1/3, right? So I could label this then as 1 pi over 3, but what is this tick mark? Half of this one, right? Why do I care about that? Well, if I had to do a phase shift, I really need to know what each of those tick marks represents. So how do I find half of these numbers? Now, remember, you could do this algebraically. If I needed to take 2/3 divided by 2, that's the same thing as 2/3, make this a fraction, times the reciprocal, right? In this particular example, my 2's would cancel and I would end up with pi over 3. Okay, so you can do it longhand here. What if I had a period length of pi over 2? What's half of pi over 2? Pi over 4. Half of a half. Now, if you don't have a number in the top here to take half of, right? We take this and it kind of looks like it doubles, which seems weird, right? But it's your denominator. So this would be pi over 4. So this is a good conversation then to have. Okay, well, half of pi over 4 would be pi over 8, which means this is 1/8, 2/8, simplifies, 3/8, 4/8, simplifies, right? So kind of helps you. Now, do I care what those are? And that's usually, that would be a great bonus question right there. Having a phase shift is something like a 3 pi over 8. So I like that bonus right there. Okay, anyway, backing up. But if I needed to figure out a phase shift and I had a different length of period, you have to consider what each of those tick marks represents. So now let's do this example. Y equals cosine of 4x. So we have now go back to what we would have called this last semester. Horizontal shrink by 1/4, right? So this is B. We really need to know what the period is because that's what we use in our picture, which is always going to be 2 pi divided by that number. Well, 2 over 4 simplifies, which is why you're going to see over here pi over 2, and we kind of already talked about this. Half of a half is a 1/4. Again, algebraically, if I didn't remember that, pi over 2 divided by 1/2, or divided by 2 would be like multiplying by 1/2, sorry. Multiply straight across the top. That's why the denominator doubles when you divide by 2. Okay. Same thing in our negative direction. And so the nice part about this technique of graphing a horizontal shrink or stretch is that now I graph like normal. I have adjusted what the tick marks represent. And so now those tick marks are just, again, holding the place for my next dot. So a cosine curve with no other transformation starts at my y-axis, one above my midline, which didn't move because I don't have any other transformation in this one. So my first start dot would be here. And now I just follow my pattern like normal. I have adjusted for the fact that there's a 4 in there by changing this marking. And now my first dot is actually over at pi over 8, but I don't care about that. It's at the first tick mark. I go to my midline, next tick mark, I go below. I don't really need to consider what those tick marks are. And we fill in like normal. Any questions? Okay, I do want to do one example where B is a fraction, just so you can see that as well. So again, rewind to first semester. We would have described this as a horizontal stretch, right? We always have to think opposite on the inside. We would have described it as a horizontal stretch by 4. Our graph will take 4 times longer than it would have before. And again, the number we see in the equation is B. The number we mark our picture with is the period. And to find that, it's always 2 pi divided by. And when we are dividing by a fraction, like I talked about on the previous page, that means we multiply by the reciprocal. Well, multiplying by 4 over 1, we get 8 pi. It would take me until 8 pi to have graphed this previously. And instead of trying to figure out what that would have looked like, still numbering out to 2 pi, we just changed the numbering. Sine curve starts at my midline, which did not move in this particular example. And again, once I've changed the numbering, I don't have to change my process for graphing. So go to the next tick mark and go up 1, next tick mark, my midline again, next tick mark, down 1, and next tick mark, up 1, midline. I said there was 2 different techniques for this. The other technique is that we didn't move or change our graphing measurement here. Well, what would have happened is this is actually represents 2 pi right here. And in my sine curve, I would have only gotten this accomplished because it would have taken me 4 times longer to get to the top of that. And that's hard to do. That's really hard to graph it that way. And I would have only seen this. And I would only ever look at this if that was like the only thing given to me was already a numbered axis. Don't do that, okay? It would be a very big graph. 4 times longer than your normal curve. Okay, our second, trig summary sheet. That's a lie. This is too early. Nope, it's not too early. Okay, what we're going to do is I'm going to gather a perfect picture of all 6 of our trig graphs. Well, we only know 2 of them, so we'll put those 2 on there right now. And then we'll come back to this next week when we start getting introduced to secant, cosecant, tangent, cotangent, and put those on there as well. But it just gives you a place to go back to that has like all the things we've learned, okay? So let's draw a perfect sine curve in order to do that. If you know how to do that, go right ahead, okay? I'm just going to talk through it as we go. I would have in a perfect sine curve had 4 tick marks out to the right labeled as pi and 2 pi, and 4 tick marks out to the left, negative pi and negative 2 pi, up to 1 and down to negative 1. I would have drawn a midline on my x-axis, not a requirement, but encouraged. That my sine curve would have started at 0, 0 without any transformations. We go over 1 tick mark, up 1. Back to my midline, down 1, back to my midline, fill in to the left, and I get this beautiful parent graph to refer to when doing my transformations. Similarly, for cosine, I would have marked out and labeled out to 2 pi in both directions. Also up 1 and down 1. Again, this one is your basic parent untransformed graph, which means our midline would be at our x-axis. My perfect untransformed cosine curve would have started at the y-axis, up 1, return to my midline, down 1, return to my midline, up 1, fill in backwards. Then we're going to flip over to the back side and we're going to talk about A, B, C, and D. I'm going to talk about them in a couple different ways here. So again, this is for you. This is your study guide. And you want to put in there things that are in your words so that makes sense, not my words if they don't make sense, as much or as little as you need to understand A, B, C, and D. One thing you do need to understand is when I hand you that DCA in like 2.5, 3 weeks, the first questions are, tell me about A, B, C, and D. Okay, so I will tell you exactly what to write on those, starting with A. A does have a vocab word, so I would describe it using that because it is the most efficient and direct way of describing A, and that is your amplitude. Now, another acceptable description of A would be a vertical stretch or shrink, because that's what it is, okay? Notes that I'm going to make for myself on my amplitude is that is my distance above and below the midline. And again, because it is a distance, my answer is always positive. Okay. In front of that, if I had a negative, that would be an ROX. And again, put what is going to make sense to you, but reminding myself of the difference between those two. If I'm looking at a sine curve, my ROX says from my starting dot, I would head down first to that next dot. Okay. And conversely, for a cosine curve, because the first dot is off of your midline, I would actually start below. So a little bit different on how we attack the whole idea of ROXs. B is one that we just learned today. Now, this is the absolute number one mistake people write on theirs, and they want to say B equals the period. It does not. They are related to each other. And so the easiest way to do this is just say that the period equals 2 pi divided by B. That is enough, but I will also put in here the other way around. B equals 2 pi divided by the period. Remember, this is what we use to label our fourth tick mark. C, easiest way to describe that is using your vocab word, and that is a phase shift. If we've got a negative, that's going to move us right. If it is a positive in there, that is going to move us left. You could also describe it as a horizontal shift. That would be acceptable. D is a vertical shift. Plus is going to move us up. Minus is going to move us down. And again, that's where I just draw my midline and then I center my entire graph around that. So continuing on, I said I was going to talk about this page for a little bit. Number one, here's your answer key to your DCA. I would use the word amplitude when describing A. I would literally just write out this equation when describing B. I would say the phrase phase shift when describing C, and I would say this phrase vertical shift when describing D. Can you use other words? Yes, but those are real quick and efficient, right? The last thing that I want to talk about on this page before we move on is, okay, then how do I use this? So when we are doing this, the number one thing I do when I start my graphing is I consider if there is a value at B. So that's the first thing I look at. And I use this to number the fourth tick mark, right? So that's the number one thing I'm going to look at, and I'm going to use it to number my fourth tick mark, and then I'm done with it. After I have looked at that and addressed it and numbered my fourth tick mark, the next thing I do is I look at the vertical shift, okay? And I draw my midline. Wherever that vertical shift tells me to move. After I've drawn my midline, the third thing I look at is the phase shift. And that tells me where to move my first dot. And finally, I consider my amplitude, and I make sure to go this distance. When I am off the midline, every single dot that is off of the midline. Now this, obviously we kind of have to keep it all in mind as we're doing this. So I didn't talk about numbering my y-axis, and that's a combo of A and D, right? So yeah, I kind of have to be bouncing back and forth between the letters, but make sure that you do address all of the letters at some point, and this helps you with a kind of a logical way to go through that. Questions? All right. First example, y equals -4 sine of x plus 2. So as we do this, again, we will attack it the same way every time, starting with our x-axis numbering. To do that, we look for B, right? If you go back to that sheet that we just filled out, the number one thing I'm going to look at is I'm going to look at what my B value is to number my fourth tick mark. And to do that, I'm going to label it with the period, 2 pi divided by B. So B is 1. That's what we've seen this whole time, right? So if B is 1, that means my period is 2 pi divided by 1, or 2 pi. That is the marking on our fourth tick mark, right? That represents the period of the graph. This one's a little tricky. This is the first time we've kind of had to do this, but does anyone recognize how high up my y-axis I'm going to have to label? 6. Just do the combination of the vertical shift and the amplitude. Don't really worry if they're positive or negative, because at some point we'll be going both directions, right? So I would definitely make sure to label up to 6. Now you can put 6 tick marks up here if you want, or you could do like 3 tick marks and label them by 2s. Okay, yes. As long as you label the numbers appropriately for that, it wouldn't really matter. Does that make sense? Yeah. So like I can't just move my x-axis up here and then call this 0, because then you really haven't moved your x-axis. So I would still draw this. If you don't want to draw an x-axis in there, it's not required, nor is a midline. So, all right, we have addressed B. Then I actually, when I go to start drawing my picture, start with D, right? In this case, D equals 2, or our vertical shift equals 2. And that is where I draw my midline. I numbered by 2s, so mine's at my first tick mark here. Then we think about our phase shift. Ooh, do we have a phase shift on this one? No, and if we don't have a phase shift, it would be 0, meaning my graph is not moving right or left starting at the y-axis. And it is a sine curve, which means my dot starts on the midline. So the amplitude and the ROX have not been taken into account yet. That's going to be with my next dot. So my next dot has to take into account that we are going to head down first, right? An amplitude of 4. So I go over to my next tick mark, but instead of going over 1, down 1, I would go over 1, down for the ROX 4, which would put me all the way down to -2. Now I have my pattern set and I fill in. So now I go to my next tick mark and I return to the midline. Next tick mark up 4, which is going to get us all the way up to 6, right? And return to my midline. Fill in the other way. Remember, if this is below, I have to alternate. So below, midline, above, midline, below, midline. Questions? All right. I think we've got 3 more total examples today. Next one, -2 cosine of x plus pi over 2. Okay, so should look very uniform every time. Again, I start by considering the B value, and our B value in this one, there's nothing written there, which means it's 1. Therefore, the period is 2 pi divided by that. Well, 2 pi divided by 1 is 2 pi, and that becomes the label on my fourth tick mark. Fill in. Considering how my vertical shift, 0, and my amplitude, 2, tells me how to label my y-axis, so I need to get up to at least 2. Draw in my midline. Well, I don't have a vertical shift, right? If there's nothing here, D is 0 or vertical shift is 0, and my midline remains at the x-axis. This is the one where we have a phase shift though. So which direction am I moving for that phase shift? Left. Now, remember that that is actually, if I were to answer that, negative pi over 2. C is negative pi over 2, or my phase shift is negative pi over 2. We can't use the word left, but that means that tells us what we're doing. My cosine curve is supposed to start 1 above. So normally it would have been here, but I would move it to the left pi over 2. This tick mark represents pi over 2 in our picture here. But my amplitude says start below a distance of 2. So instead of starting above 1, I would go below because of the ROX, and because of the amplitude, I'd go below 2. Always that distance from my midline. That would be my starting dot. I'll pause there before I fill in. Are we all okay with that starting dot? Sometimes the cosine, the amplitude is the hardest one to get in there. It applies to your first dot also. Okay, so fill in. I am off my midline, so I must return to my midline and then go the other way. So this is below, my next one should be above. Midline, below, midline, fill in. And again, the whole colors and indicating your starting dot and all of that not required. Okay, just so it's easier for you to see in your notes here. All right. Second to last example. Y equals sine of 3x plus 1. Okay, the first place my eyes go is B. In this case, we have a B value. If B is 3, the period is 2 pi divided by that, and that does not simplify, right? Kind of an ugly one, and that's okay. 2 pi divided by 3 is 2 pi divided by 3, 2/3 pi. We already had that example at the beginning. If it's 2/3, half of that is 1/3, right? So half of that would be labeled as pi over 3. I have a vertical shift of 1 and an amplitude of 1, so I only need to get up to 2 at the most. Draw in my midline, up 1. And that's all my transformations. So now my sine curve should be very normally spaced around that midline, starting on my midline. No phase shift, so it starts at the y-axis. Over 1, up 1, back to my midline, over 1, down 1. Make sure you alternate up and down so that if I were to trace this, I would say above, below, alternating all the way across my graph. Questions? Okay, you're ready for a complex one. This is about as complex as it's going to be. All I could add to this is like a ROX or an amplitude. And so y equals cosine of 1/2 x plus pi minus 1. All right. What makes this one challenging is the combination of a change in the period and a phase shift, and paying attention to what those tick marks now represent when we change the length of the period. So first of all, having a B value of 1/2 means that the period is 2 pi divided by 1/2, which is actually 4 pi. So it becomes 2 pi times 2/1, or 4 pi. I do have a vertical shift of down 1 with an amplitude of 1. And so I would draw my midline down 1 to start with. It's the whole phase shift thing that can be a little tricky. And our phase shift, again, opposite. So if it says plus, I think left. Now, on most graphs, left pi would have been right here. Okay, but we altered how we labeled things. So actually left pi only moves over to your first tick mark. So if you change it from being 2 pi, you got to pay attention to what do those tick marks actually represent. So instead of starting my cosine curve here at 1 above my midline at the y-axis, because of the left pi, my cosine curve would actually start 1 above my midline, 1 tick mark to the left. Question? Yeah, not often. Not often, but we might have something like where we're supposed to move to the left on pi/2 and our tick mark represents pi. So then you'd have to go like halfway. That's as ugly as it'll get. Okay, so now fill in my pattern. I am currently 1 above my midline. So my next dot should go to my midline, 1 below, midline, 1 above. Now notice I never say what the values are because we don't really need to. If we did a different technique for doing our horizontal shrinks and stretches, we would care more about what values these are falling at. But because of our technique of just relabeling the 4th tick mark, it makes it a lot easier to do that. We don't really need to know where those dots are falling. Questions? Like I said, that's about as tricky as it gets. All I could add to this was either maybe like an ROX or an amplitude change here, but a phase shift with a change in the period can be tricky. All right. There is one thing I want to look at here. This is what your assignment's going to look like. Still identifying your amplitude, phase shift, vertical shift. I do want to remind you that your amplitude is always positive, right? So the fact that this is a -3, I'd still just put a 3 here. The last thing I want to remind you of, this is not B. From the equation, I will identify what B is, but to get the period, I will take 2 pi divided by B, right? That's how I identify. So the fact that B is 1, this would be 2 pi. And conversely, you're going to start kind of getting into the idea of writing equations. And when we are going the other way, they will tell you the period. So this would be an example of kind of the end of your notes, preparing us for and kind of getting ready for writing equations on Thursday. And so when this is given to us, again, they'll always give us what we don't want. Well, our equation has a B in it. So we would have to move from period being 4 pi to B being 2 pi divided by the period, our period being 4 pi. Those pi's cancel, and 2/4 would be 1/2. So in the place where B is in our equation, we would put 1/2, not the 4 pi that we see for the period. Okay. So always 2 pi divided by, to flip back and forth between period and B. Any questions for me? All right. Your assignment tonight is a worksheet, and I will get that handed out to you right now. Let me